All right, everybody, today is Monday, November 9th, and our science read aloud is all about solar energy and uneven heating of the Earth's surface. Here's the read aloud that will help you answer the 3 think about it questions for today. Stars create a lot of energy. Energy radiates from them in all directions. Most of this energy streams out into space and never hits anything. A small amount, however, hits objects in the universe. When you look into the sky on a dark, clear night, you see thousands of stars. You see them because a tiny amount of energy from the star goes into your eyes. During the day, you are aware of the energy coming from a much closer star, the sun. When sunlight comes to Earth, you can see the light and feel the heat when your skin absorbs the light. Heat and light from the sun are called solar energy. When light from the sun hits matter, such as Earth's surface, 2 important things can happen. The light can be reflected or absorbed by the matter. If the light is reflected, it simply bounces off the matter and continues on its way in a new direction. But if the light is absorbed, the matter gains energy. Usually, the gained energy is heat. When matter absorbs energy, the temperature goes up. Heating it up. The amount of solar energy coming from the sun is about the same all the time, but the temperature of the Earth's surface is not even. Some locations get warmer than other locations. Why is that? There are several variables that affect how hot a material will get when solar energy shines on it. The table below lists several of these variables and how each affects the temperature change of the material. Variable: length of exposure. Effect: longer exposure leads to higher temperatures. The second variable: intensity of solar energy. The greater intensity leads to higher temperature. The third variable: angle of exposure. More direct angle leads to higher temperature. The fourth variable: the color of the material. Darker color leads to higher temperature. And finally, the properties of the material. Water shows the least temperature change. Length of exposure is how long the sun shines on an object. Intensity of solar energy is how bright and concentrated the energy is. For example, if the light travels through clouds, it will be less intense. Clouds reflect and absorb some of the energy before it gets to Earth's surface. The brighter the sunlight falling on an object, the warmer the object will get. Angle of exposure changes throughout the day. The morning sunshine comes at a low angle and is less intense and weak. Midday sunshine radiates down from a high angle and is intense and strong. Different colors absorb solar energy differently. Black absorbs the most solar energy and white absorbs the least solar energy. And of course, the chemical properties of the materials affect how hot they get when they absorb solar energy. Water heats up slowly and soil heats up rapidly. They absorb the same amount of energy. Water cools slowly and the soil cools rapidly when they are moved to the shade. So here was the story about the beach to kind of give you a real life example of solar energy in action. And it says, imagine a summer trip to the beach. On a cloudless day, the sun shines down with equal intensity on the sandy beach and the ocean. It's a hot day. When the car stops in the parking lot in the early afternoon, the pavement in the parking lot is super hot. The black asphalt has absorbed a lot of solar energy and its temperature is 50 degrees Celsius. You walk across the parking lot and ouch! Whew, it's hot. And you get onto the white sand. Phew, the white sand isn't as hot. It is a bearable 32 degrees. You keep moving toward the water. You finally get relief from the intense heat because the temperature of the ocean water is 22 degrees Celsius. The asphalt, sand, and ocean water were all exposed to the same intensity of solar energy for the same length of time, but they all are different temperatures. Why is that? Black asphalt absorbs lots of energy and gets very hot, while the white sand reflects a lot of the solar energy. The light-colored sand doesn't get as hot as the asphalt, and water absorbs a lot of energy, but it stays cool. The temperature's Earth's surface is not the same everywhere. Land gets hotter than water in the sunlight. Land gets colder than water when the sun goes down. Land heats up and cools off rapidly, meaning quickly, while water heats up and cools off slowly. The result is uneven heating of the Earth's surface. Uneven heating worldwide. You can experience uneven heating of the Earth's surface with your bare feet when walking on asphalt. The difference in the temperature between the asphalt and the water is obvious. On a larger scale, the whole planet is heated unevenly. The tropical areas, or the tropics near the equator, are warmer. The polar areas are cooler. That's because the angle of the exposure of the solar energy is more direct in the tropics. The illustration shows how sunlight comes straight down on the tropics, but the sunlight comes at a sideways angle toward the poles. You can see how the same amount of light is spread over a much larger area in the north than in the tropics. This results in more heating in the tropics and less heating in the northern areas. All right, think about it questions that you'll answer on your Google form is number 1, what causes Earth's surface to heat up? Number 2, what are some of the variables that cause uneven heating to the Earth's surface? Number 3, what happens to the temperature of equal volumes of soil and water when they're placed in the sunlight for 30 minutes? Good luck, and make sure you click submit after you're completing your short answer Google form.